Okay. The gyroscope is gyroscope gyroscope என்னன்னா இப்போ ஃபோன் எடுத்துக்கிட்டு இப்போ யூடியூப் வீடியோ எதுவும் பார்க்கணும் சார் நார்மலாக ஃப்ரண்ட் சைட் வீடியோ வச்சுக்கிறப்போ ஒரு வீடியோ வந்து ஷார்ட் ஆகுது இது திருப்பினா ஃபுல் ஸ்க்ரீன் வருதா அதுக்கு எப்படி தெரியுது திருப்பி தெரியுது ஆப்ஷன் கொடுக்காம நீ திருப்பினா அதுவே ஆட்டோமேட்டிக்காக எடுத்துக்கிறது மோஷன் சென்சார்னா அப்போ நீ யூடியூப் பண்ணனால அதை செய்யணும் சில கேமில் இப்படி லெஃப்ட் சைடு ரைட் சைடு சப்ஜி சர்ஃபர்லாம் சிலது ஆக்டிவேட் பண்ணால் லெஃப்ட் சைடு இருக்குன்னா அது லெஃப்ட் சைடு அது பார்த்துருக்கேன் ஸோ இது எப்படி ஒர்க் ஆகுதுன்னா இது பேர் கைரோஸ்கோப் இது என்ன பண்ணால் அந்த யூஸ் பண்ணுற டிவைஸோட ஓரியன்டேஷன் எப்படி எந்த ஆங்கிள் தெரிஞ்சு ஸோ உனக்கு இப்படி வச்சு யூஸ் பண்ணுறது அப்படின்னா போர்ட்ரேட் இப்படி வச்சு யூஸ் பண்ணுறது லேண்ட்ஸ்கேப் இந்த ரெண்டு மூணுக்கும் டாகல் பண்ணுறது இருக்கிறது கைரோஸ்கோப் கைரோஸ்கோப்பு நம்ம மொபைல்லே இருக்கும் சில மைக்ரோ கண்ட்ரோல் வந்து this will be plate 1 and this will be plate 2. So you can notice that there is a distance between these two, and similarly on all the parts we can see that there is a distance. And similarly we have a distance here as well. So this distance we will say D. So we already know that when there is a change in D, the force, electrostatic force also varies. We'll use that to find out what is the change in the capacitance also and also the electrostatic force. The capacitance also changes based on this one, right? So we see that the distance changes when it moves this way and also changes here because the distance over here changes, right? So the distance changes and correspondingly the capacitance value also changes. This type of capacitor is called an interdigitated capacitor, as in fingers are called digits, and this type of setup is called an interdigitated capacitor. So what we'll do is we'll use this principle and make a MEMS device out of it. So what we'll do is we'll micro manufacture a proof mass like so. So this is a micron sized device, micron sized mechanical structure. So we have a bigger structure. This structure has a heavier mass compared to the other parts. So this we will call it as proof mass. And to the other end we'll have these two components. We'll keep them close to each other, and what we'll do is we'll fix these parts. So these two ends are fixed, but the proof mass is free to move. It can move in this direction and also this way. Okay, so we'll see what happens. So now what happens here is, so when this is free to move in this direction, so it can move this way. So this we'll call it as x-axis. Okay, now we'll say this is x-axis. So it is free to move in x-axis. So negative x, and this direction it is positive x. So these two we'll consider as capacitors, as the parallel plate of the capacitors. So when it moves this way, the distance over here changes. See? So it is farther away from this plate and it is closer here, and vice versa when it moves this way. So by this way, what happens here is the capacitance value changes, and this capacitance value can be used to find out in which direction it is moving. So now it is in x direction. So what happens if it moves this way? Now it becomes y direction. So if it moves this way, the distance between each individual fins of the digits of the capacitor changes. So you can see here, when it moves, the distance between each digit changes. So here we can say it is positive y, and here it is negative y. So it moves in this direction as well. All right. So what we'll do is we'll now consider that this surface as another part of a parallel plate capacitor. We'll call this, we'll say this surface to be connected to this one. There is a voltage supply between these two. So this surface is one of the parallel plate capacitors, and this surface is the other plate. So what happens here is it is free to move in this direction as well, in the z axis. So this is negative z and this is positive z. So it is free to move in this direction as well. So what happens when this setup is kept within, let's say, our car, and our car is moving in this direction. Let's say it is moving in this direction. What happens to this one? It will move, because of inertia, it will move this way. Since the car is moving this way, because of inertia, this moves this way. So we can find out it is moving in this direction, and this can be used to as a part of the accelerometer. And so we have the orientation of mobiles in like landscape and portrait mode, right? So that can be found out by using the movement in x and y direction. So this can be used, and the tilt of our mobiles can be done by using the z-axis movement. So that's why we have it from the modern iPhones and so on. We have the 3-axis accelerometers. This can be used to find out in which direction or in which direction the system is moving towards. So this is how a MEMS accelerometer works. Thank you.